Hello dear viewers, a very warm welcome to PCE Instruments. Today we want to present to you the mobile hardness tester PCE 900. At the mobile hardness testing there are different procedures. For example, the UCI process, which is a state procedure which functions using the ultrasonic procedure. There's also the Subler procedure or the Leeb procedure, which is a dynamic hardness testing procedure, also ideal for the hardness testing. The PCE 900 is based on this procedure, suitable for special applications. The measuring device is equipped with different materials, for example for steels or soft metals. Furthermore, the measuring device can measure in the Leeb scaling, because it is a Leeb testing measuring device. Also in hardness scales such as Rockware or PCAS or others. We have the device here. We can have a look at the contents. To this belongs the display unit. Then we have a hardness comparing block. On this comparing block the hardness is graved in at Leeb. In this case it is 774. With this comparing block you can calibrate or adjust the device or just compare to see if the measuring exactness is still there. Also in the delivery is the rebound or firing pin D with cable. Also we have in the delivery a cleaning brush. It is to clean the firing pin regularly. Through the abrasion forces, dirt can arise. Also in the delivery, there's an additional cap. You can screw it to the impact body instead of the original. The diameter of this cap is a little smaller as the standard diameter. That means with smaller constructions or the surface is smaller, it is useful to use this cap. The device is battery operated, that is why there are batteries in the delivery. Furthermore, there is a calibration certificate. Which documents the measuring exactness, and last but not least, a multilingual user manual, as well as a hard case, with which the device is delivered with. So now we can start with a test measurement. For this we attach the rebound or firing pin to the measuring device using the cable. The firing pin has to be loaded. For this the black cartridge is pushed down. But first of all, in the measuring device the right carrier has to be set. First of all it is switched on using the on-off button. In this case we want to measure aluminium, so we have to set the right option. For this we press the mat button 6 times. Bottom left of the display you can see the figure 6. In this device, number 6 stands for the core line of aluminium mouldings. Furthermore, we have to decide which hardness scale we want to measure in. In this case the hardness binary scale, which means we have to press the scale button. Top right of the display you can see the symbol HB, which stands for hardness brine. Following this we can do a measurement. After the measuring device is loaded, you have to press it firmly onto the surface of the material to be tested, and using this button is triggered and hits the surface and the measurement is done. By using the rebound speed you can see what the hardness grade is. The measured result is shown on the display. In this case the aluminium moulding piece has a hardness grade of 81.3. It is practical on more than one spot to test the surface to get a middle value. Bottom left of the display you can see 1 of 5 measurements have been done. That means to become a middle value, 4 furthermore measurements can be done. So let's just do that. The middle value for this moulding piece is actually 84.1 Brinell. Concerning the probe preparations, there are some things to consider. For this it counts on the surface state or the surface roughness. The weight of the probe and the thickness of the probe, and the hardening depth in case it is a hardened probe. By the surface condition, you say that the surface roughness should not exceed 2 μ, as it should be, for the firing type D, which is in the delivery with this measuring device. Talk about the weight of the probe, you say that everything over 5 kilograms is okay. Beneath this weight, the probe should be docked onto other pieces or onto a workbench. For this you can, for example, use coupling D, which is on our home page. The probe thickness should be at least 3 mm. Beneath 3 mm can cause measurement faults. By the edge thickness, by hardened pieces, the edge should not be hardened less than 0.8 mm. By longer hardness depth, it can cause measurement failures. The geometry of the component also plays a role. As you can see by this object, the measurement on a smooth surface faces no problems. The firing can be positioned exactly. On curved pieces or round pieces, like this in this area or on a shaft, it is better to use concave adapters, which you can also find in the optional accessories for this measuring device. So now we want to have a look exactly at the technical data of the PCE 900. The measuring area is between 200 and 900 hardness Leeb. This hardness can be converted into other hardness scales. For this there is Hardness Rockwell, Hardness Rockwell B, Rockwell C, Hardness Brinell, Hardness Vickers, and also Hardness Shaw. These hardness scales can cover different hardness types. That means the measuring device can measure different materials such as steel, stainless steel, moldings, and different soft metals such as copper or brass, bronze, and aluminium. These materials have to be chosen before the measurement is done. That also includes the hardness scale, so that the measuring device is set properly for the right measurement. The measuring device has also a ring data storage, which means the data can be stored and documented. Furthermore, there is a 232 interface, and the operation runs, as said, over 3 AAA batteries. Further equipment is also available. To this belong such things as concave adapters, when for example you want to measure round surfaces or want to measure pipes. It is useful to use such adapters because the centering of the measuring device works better. Further information you can find on our homepage at www.pce-instruments.com.